Hi, this is Paul Edwards with Danmark Company. I will be doing a continuing education about the capabilities of the Danmark dip system, and I'm also going to go over some just general information regarding the use of acidified sodium chlorite, and I'll talk about some of the new tools that we have that are available for addressing measuring acidified sodium chlorite. This is going to be a great opportunity to learn some stuff. First of all, I want to talk about safety. You should always have chemical resistant gloves for utilizing your antimicrobial intervention. You want to protect yourself from chemistries that could be a challenge to you. The acidified sodium chlorite that I'm talking about today is a neutral pH, but nevertheless an individual may react unexpectedly to a chemistry. No one can actually know what people are allergic to on the broad. Now, if you have an individual case history where you actually know this person has had a previous issue with a certain chemistry, then you want to prevent that. But and for the most part, it's hard to know in advance when somebody's allergic to something. So you'd want to take precautions that would keep that person from being exposed to a chemistry that could very well be a chemistry that causes an allergic reaction. Of course, you have safety glasses to protect your eye from any kind of splashing of chemistry. And since I'm going to be working with water today, I'm not wearing long sleeve shirts, but a long sleeve shirt is a way to protect yourself from splashes as well. But I'm going to be working with water only today, so we're going to be okay there. A couple of things to remember is that you can go to the website www.danmarco.net and look at other videos that will demonstrate what the actual chemistry looks like in the way of color, because with the acidified sodium chloride at a neutral pH, you will see that the chemistry that I work with at Danmark and I do validation studies is significantly yellow or green chemistry, which is very active chlorine dioxide present. And through this study, or this continuing education today, I will be touching on chlorine dioxide as one of the components of acidified sodium chloride. So I just want to let you know that we will be discussing it. So right now what I'm going to do is I'm going to turn the water on to this pump system, the dip system. And as I turn on the water, and as it goes through the system, we'll notice that the tank will start to fill up. And you see the tank filling up here. And just as a reminder, the Danmark dip system is designed that when this flow elevates, the water stops flowing. You notice that the water stops flowing. When it goes back down, the water starts to fill again. Now, what's important about this right here, what you're seeing is when the float goes up, and it's a see-through float. When the float goes up, the water definitely is going in, and when the float goes down, the water is no longer going in. So that's a very important consideration regarding the system is concerned, is that it has that function. That is called the floating lever, floating controller, you can call it anything you want. I call it the floating lever. But the nice thing about it is that when you have this floating lever elevated like this, it turns off the refill portion of this system, and then of course when you push it down, what it does is it goes on and activates it again. So I'm going to demonstrate that. Once again, there's previous videos that will explain that to you, so I'm just briefly going over that. There's actually, the purpose of this study is a totally different one. But here is where, if you had poultry, if you had beef, or you had produce, or if you had seafood, anything that you have a food safety concern with, if it's equipment that you want to sterilize, or I should say sanitize, not sterilize, you would go through that. But you would put it in a basket like this, and then you would, as the basket goes in, it depresses the valve, and then bam, when you take it off, it no longer depresses the valve. So when here's your valve upright, because the water has pushed it up. The level of the water is pushing it up. When you put the basket back in, it pushes it down, so it allows the chemistry to refill. And it's approximately refilling at a rate of 8 ounces. Basically what you're doing there is you're filling out. Now, there is a video that you can look at, and you can see what the actual replenishment rate is on this. And so that's available to you on the other CD, or excuse me, another video on the website that you can look at that. So you're familiar with the dip system from the point of the floating lever and how that goes up and down, okay? So now, when you look at this chemistry, it's clear right now, but let me talk about what we do know about the chemistry when it has the acidified sodium chloride, chlorine dioxide in it. First of all, we know this. We know that this tank acts a lot like a contact chamber. Okay, and what is a contact chamber? For those of you that are in potable water treatment, or have had some background in potable water treatment, or have been involved in wastewater treatment, the wastewater treatment there, in those two environments, we have what's called a contact chamber. And here's what a contact chamber's intended purpose is. The contact chamber its intended purpose is that as long as a specific amount of chemistry is in that chamber, that active ingredient of the chemistry, when it sees an organism, it will reduce the quantity of that organism. It will reduce it. And a lot of times those organisms can be measured differently, okay? For example, you could have an organism be measured in logs, okay? You can have organisms be measured in coliforming units per gram. You can have organisms measured in coliforming units per liter. There's so many different ways that you can measure organisms, volume of organisms, that I want you to go on and do the research and get a general understanding of all these different numbers. Like, for example, you could say, how do you measure volume, quantity volume? Well, you can measure it by using a cup, or you can measure it by using an ounce, or you can measure it by using a liter, or you can measure it by using weight. So you're getting the point there, is that volume can be measured in different ways. And so, you know, how you go about measuring microorganisms is totally left up to you. The thing to consider is that what is generally uniform when you're considering supporting documentation. So, you know, if coliforming units per grams is what you normally see, if log reduction is what you see. Whatever your normal reporting method for volume is, it is what it is, okay? Well, in the wastewater treatment plants, in the contact chamber, they have organisms coming into the contact chamber at a certain volume. And then they leave the contact chamber in a different volume. And ideally, that different volume is lower. So let's say, for example, and I'm going to come up with some broad numbers. Let's say that an organism arrives into the contact chamber in a volume of 100. And then as a result of the chemistry in the contact chamber and the amount of time present in that contact chamber, it leaves at a certain lower volume, okay? So it stands to reason that if you have a similar time and a similar concentration, you will have a similar reduction, right? You got me? I haven't lost you? So that right there is a no, and you know, is generally understood, okay? So what we're using in the world of acidified sodium chloride is we're using acidified sodium chloride, which is measurable by a certain test kit. Then we're measuring free chlorine dioxide, which is measurable by another kit. And then you have pH, which is measurable by another kit or device. And the whole purpose of those three parameters is to create a general understanding of your contact chamber. And in this case, it's called a dip system, but it is a contact chamber. And don't kid yourself, it is. This is exactly what we're talking about here, is a contact chamber. In the wastewater treatment and in the potable water industry, the reason why contact chambers are used is because you can get a large volume through the contact chamber with the same purpose, which is to microbially reduce whatever the volume of bacteria is present. So that's not going to change. Over the course of years, the contact chamber, because it was greatly misunderused or misunderstood or incorrectly used or incorrectly understood, whatever the reason was, the contact chamber has gotten a new term assigned to it. It's called community bath now. So whenever somebody says community bath, it's reflective of something bad. And that evolution, that change of the contact chamber, of going from that to being a community bath, whatever the reason it was, it doesn't matter. The fact is that it was incorrectly used, and that is the reason why that evolution occurred. So in a recent study that I did with salmonella, and we were looking at the contact chamber, the very important point to remember about that study was, when you do an inoculation study, you're using a high enough volume of bacteria so that you can measure the difference that occurs in a contact chamber, okay? So what happens is you use this high volume of bacteria of, let's say, 8 or 9 logs of bacteria, which are, you know, a lot. It could be like 50 million organisms. And then what you do is you sit there and you watch, okay, what happened? What was the measurable reduction of that organism through this contact chamber, this dip system, or community bath, if that's what you want to call it. And whatever that is, you report it. Now here's the problem with high volumes of bacteria for the sole purpose of showing a measurable difference. It doesn't reflect the real world. So what happens is, when you're looking at microbial reduction of a contact chamber for the purpose of microbial reduction, then you use a high volume of organisms. But when you're looking at a survivability of an organism within a contact chamber, then you look at normal volumes of bacteria, which are significantly less than 50 million coliforming units per gram. And so basically, one of the things that I want to make sure that you understand, I think it's very misunderstood, is that the bacteria going in to this contact chamber has got to have a well-defined purpose. Are we going into this contact chamber for the purpose of measuring microbial reduction, or are we going into this contact chamber to see the survivability of an organism over the course of a period of time? Now let's think about a wastewater treatment plant for a second. A wastewater treatment plant has a significant amount of microorganism loading, okay? Why? Well, if you're looking at E. coli and you're looking at what's coming from the bowels of human beings, going through a domestic waste line into a contact chamber, well, first of all, what you have is you have a lot of bacteria that you've got to address within that contact chamber. And so in the wastewater treatment, they use a great deal of chemistry in order to reduce that. I mean, we're just huge amounts of ozone or huge amounts of chlorine dioxide, huge amounts and high volumes, because you've got like a million gallons in, and so you've got to offset those million gallons of high load organisms with an equally capable amount of volume and chemistry that will reduce that organic load or that bacterial load, so that once it makes its way through the contact chamber and into an effluent from that contact chamber to a river, then the only thing they have to worry about is removing the resultant antimicrobial agent. So in the way of a wastewater treatment, prior to going into a river, they're going to dechlorinate if chlorine is being used to be the oxidant of choice to remove the bacteria load, okay? So I don't really want to make this too complicated, but what I'm saying is that a real-world scenario in food safety is more like what we see in potable water. In potable water, we still have a contact chamber, but the amount of chemistry that is being used in potable water is significantly less than the amount of chemistry that's being used in a wastewater treatment plant. And the reason why is because the load is significantly different and significantly lowered. Okay, so that happens in food safety. In food safety, when you have a boxed poultry, a boxed seafood, a boxed beef, and you're looking at the incoming load, it's more like a potable water, and you're going to use the chemistry and the contact time that is more replicable to that of that's on meat. So when you do the study, you're going to use a same amount of volume that you would normally find in meat. That same amount of volume would be put into this to test its survivability in this bath, okay? So if you're replenishing, each time you dip, you're replenishing, then you are reboosting the chemistry, the active chemistry in this tank, okay? And it's up to scientific data to demonstrate that this is a problem or not, okay? And I find that when you have a presence of free chlorine that is at or above 3 parts per million free chlorine, at or above, present in this tank, 3 parts per million chlorine, you're not going to have significant microbial growth, and you will not have significant cross-contamination in this tank. There's plenty of supporting data out there in that regard, and so I want you to know that, okay? The question is what is the amount of organisms that you're going to put in to test that theory? And over the course of the next year or so, we'll push that question, and we'll do some research, and we'll have that explained. But I just want you to understand that we understand the challenge and the concerns with community bath, and we will address it little by little, but it has always been a very good idea. Community bath has always been contact chamber. It hasn't always been a community bath. It's always been a contact chamber, but we gave it the name community bath. It wasn't me, it was somebody in the know or in the unknown that came up with that term. And what that term really means is that this went out of control, okay? There was no replenishment, there was no control of the microflora developing in here, and that lack of control evolved the new terminology called community bath. It's highly regulated, but many plants still use some form of a contact chamber, and the reason why they use this form of contact chamber is because it's one of the best ways to lower temperature. It's also one of the best ways to still get surface area decontamination. So as a tool, it's very effective. So some companies still use this tool. I'm just suggesting that this is one of the best tools that are underutilized for all the wrong reasons. And so we're going to definitely explore that at Danmark Company for a while to come, okay? So basically you have this floating lever. It's replenishing every time that goes down, and it's replenishing your free chlorine dioxide and your total acidified sodium chloride. So how is Danmark going about improving the accumulation of information regarding the free chlorine in this tank? Because I'm not trying to confuse anybody here. The active ingredient to control this tank is not the acidified sodium chloride. It is the free chlorine dioxide. So please don't misunderstand me. Even though I'm talking about acidified sodium chloride, I'm talking about pH. I will try to explain the connection between those. But more importantly, and what I want to put on top of your thinking cap, is the free chlorine dioxide. So what I have here is an ORP meter, and the purpose of an ORP meter is stands for oxidation reduction potential. I'm going to ask you to go on and do your study on the internet and really get a good understanding of oxidation reduction potential. It wasn't my purpose to explain oxidation reduction potential to you, but if you go to some of my other studies, you'll see that. I also have a free chlorine dioxide titration kit. Free chlorine dioxide titration kit. And just briefly to explain what that is that you've got a free chlorine dioxide test kit like this, okay? It's manufactured by a company that we're their master distributor for, okay? Free chlorine dioxide test kit. That free chlorine dioxide test kit will measure free chlorine dioxide test kit. Once you measure the free chlorine dioxide test kit, you can use the ORP meter to give you another volumetric reading. So this measures in millivolts. It gives you an idea of what millivolts exist when you have free chlorine dioxide. So if I measure this tank, and this tank has 3 parts per million free chlorine dioxide, this right here is probably going to tell me it has either 2 or 4, because every drop represents 2 parts per million. So it'd probably say you got 4 parts per million free chlorine dioxide. This ORP meter will say, based on the measurement that I'm getting from this ORP meter, you're at let's say 630, probably about 614 millivolts. So you have 614 millivolts. So you can say that at 4 parts per million with one test kit, it is equal to 614 millivolts of the ORP meter. And then we come over here to this test kit, and this test kit measures accurately, and it says, guess what? You're at 3 parts per million. You're not at 4 parts per million. So we know that this test kit said it's 4 parts per million, but this test system right here tells you, bam, you're actually more accurately at 3 parts per million free chlorine dioxide. But all those tools just help you manage this dip system, which is very important. You want to manage this, okay? So Danmar's all excited about their dip system, right? And we got this lever that goes up and down. It's constantly replenishing whenever I dip with this basket here, right? I put everything in this basket. The basket goes underneath the water. It saturates whatever the product is that you're treating. Bam. Then what happens? Okay? See the camera? Okay, I'm moving it over here to the edge. Now it's out of sight. You're going like, Paul, why is that out of sight? I can't see where that went. Well, here's the part that I'm excited about and I'm going to tell you about right now. See this white container there? Okay? Here's where my basket is. Okay? My basket's just been dipped. Look what I got here, guys. Yeah. A spray wand. Okay? So now I've gone from a dip to a spray wand. I'm going to turn my water supply on. Guess what now? I have now got a spray system. Let the water come through. See the volume coming out of that? Okay? See that? I'm going to go on and try to bring this closer so you can see that. See it wetting my hand? That's the nozzle, buddy. Right there, that nozzle, you see it? I've got a cup there. Okay? Now what I'm doing is I'm taking my parts, okay? I'm taking my parts and I'm spraying both sides of the part after I've dipped it, okay? So with the Danmark dip system, you can take a part and I can spray it, okay? Now let's say that I've got a part that it's multi-sided part, okay? It's a multi-sided, multi-directional item, hard to get to places and things like that, okay? Yeah, we can get to that hard to get through places simply by moving the part underneath the spray wand. So I'm going to come back over here. I go to the spray wand. Guess what now? You see that? Me spraying this bottle? I can get the cracks, the crevices, all the different parts of that, okay? If I was doing a dye tip, you can go to the section of Danmark.net, that's danmarco.net, our website. You can go to the section on the video where you actually will see the dye test being done, where you take the dye and you actually look at the dye and see how well the dye covers a piece of meat on the dip system, okay? Well, the same thing could be done with this hand wand. You could sit there and you can spray it, okay? Now, guess what? You just sprayed the part, you move the part, whatever. So, the point I'm trying to make here, folks, is that the same chemical feed system that is feeding the dip system is also the same chemical feed system that's feeding your hand wand. So with the Danmark dip system, you've got basically two capabilities. You've got the dip, and then you follow it up with the spray. And that makes it a very versatile device, okay? So now what I'm going to do is I'm going to go back. You see how this is starting to, the lever is starting to go up? You see how the lever is starting to move its way up here, and then also if you listen to the pump in the background, you're starting to hear the pump not function as much as it did before. It's actually slowing down. Now listen to the sound. When I put this basket, you hear that? See how it's totally depressed? Okay, now guess what? I pull it out, it's floating. Now I've got some customers that say, hey Paul, what about the fact that this handle sometimes is underneath the water, okay? The antimicrobial, like sometimes the tank will fill up above this floating lever, and they say, hey, well, what, when the floating lever is underneath the solution, and what if the solution, I can't see the floating lever, does this thing still work? Yes, it still works. Your pump's shut off when the floating lever is underneath, and when you put that the basket here, when you take the basket and you put it underneath, it still depresses the floating lever. So it's the fact that you can't see the floating lever above the level is not an indication of whether this is going to work or not. It just means that the floating lever is underneath the water level, but it still functions, it still operates correctly. So I just want you to know that. Don't worry about that too much, okay? So I just introduced the hand wand, okay? The hand wand is a secondary application of the same chemistry, okay? Just introduced that to you. It's kind of neat. I'm excited about it. And versatility with technology is so important, and we've built versatility into our system here with that. But here's the point I want to make, okay? Our supporting documentation has long since given you volumes to treat with. I can assure you that with this nozzle tip and larger nozzle tips with larger orifices would give you greater volume, and with the greater volume of antimicrobial agent being applied to the surface of that product, you're going to have more saturation, more reduction, more control. We're living in an age where recalls are being implemented on Salmonella, Listeria, Campylobacter, and E. coli. Okay, these problems are not going to go away for us, folks. All I'm suggesting is let's use proven methods such as a contact chamber. Let's use proven methods such as handheld direct application of a spray wand. Let's take these proven methods and utilize them in our system so that we're not affected by recalls. Well, I really appreciate your business. I really appreciate you taking the time, and you're welcome to give me a call at 817-822-5767, or you're able to send me an email at danmarco1@msn.com. We thank you and we appreciate your business, and if there's anything we could ever do for you, please do not hesitate to call us. Have a great day.